You guys want to learn about noise abatement and what to do if you have a slats and flaps jam situation? I'm glad you asked. Let's get right into it. Hello ladies and gentlemen, welcome back on board. We're Waypoints Aviation and back in the Airbus A320 flight simulator, good old Alpha 6 Alpha Mike November. And today we are in Gatwick, London Gatwick Airport. Echo Golf Kilo Kilo, that's the ICAO code for us today. And I had a very interesting request from a subscriber in the comment section, asking for me to explain noise abatement and how would you go around doing noise abatement. And so noise abatement, put in very simple terminology, is a procedure that basically prevents noise pollution of aeroplanes affecting the areas around the airport. Okay, now in most cases, airports, especially international airports, you'll find them in built-up areas that are surrounded by, you know, neighborhoods, suburbs, and, you know, all these people, they don't necessarily enjoy the noise of aircrafts, you know, blasting their way out of the airport, you know. So and in most cases, sometimes they would complain, you know, hey, it's too loud, I can't sleep, and all that kind of stuff. So noise abatement is an actual procedure that we have to follow in some airports. You'll find we don't really have noise abatement procedures in Dubai, but which is where I fly out of, which is my home airport. But we do have them in Europe, mostly in Western Europe. We have them in the UK. You have them in Canada and America. So there's a few countries that actually have active noise abatement procedures. So which is why I've put us in London Gatwick today, because London Gatwick does have some noise abatement procedures, very specific ones to be more precise. And basically the noise abatement procedure, depending on the type of procedure that you have to follow, you've got it's NAPD, all right? So you've got NAPD 1, NAPD 2, you've got ICAO A, ICAO B, and then of course I'm pretty sure the FAA has their own as well. So these different procedures are what the airport will tell you applies in that situation. So you always have to check your charts and your airport briefing notes, and it's going to tell you exactly what you have to do for the noise abatement procedures active in that particular airport. So it's, you know, we don't just program the flight plan and then just, you know, taxi you over to the runway and take off. You know, we have to take these things into consideration, because if you do not follow the procedure, it could become a violation and can be a finding, you know, brought up against you and the crew. So we do have to take these kind of things into consideration today. All right, so what I'm going to do is I'm actually going to plan a flight from here, London Gatwick Airport, over to Amsterdam. A quick short flight, right across the English Channel into Amsterdam. And what I'm going to do is I'm going to show you how I prepare and brief myself, and of course my co-pilot, for the noise abatement procedure, and then look at the limitations that we have, or the constraints that we have to follow based off these procedures. And then I had another interesting request, which was a flaps and slats jammed, or slats and flaps jammed situation. Now, as you know, let me get the hydraulics on today. So I just powered on the electrical hydraulic pump, and let's see here. I'm gonna bring it up so it's pressurized in the yellow system. So, and then the PTU is going to pressurize the green system. So now I can actually operate the flaps and flight controls right here on the ground without having to start the engines. All right. So as you can see now, as I move my side stick, the flight controls are working. All right. Now what I want to show you is the flaps. All right. The flap indicator, the flap selector, is right over here on the right hand side of the center console. You've got settings from 0, 1, 2, 3, and 4. All right. Which is nice, which is great. However, when you select flaps 1, all right, which I've done just now, as you can see, because the aircraft is on the ground and the logic system of the aircraft dictates that we're going to be taking off because we're on the ground, and we're at a speed below 210 knots, it's going to deploy 1 notch of slats and 1 notch of flaps, which is what we need for a flaps 1 takeoff. So that's why whenever we're doing a takeoff at flaps 1, you'll hear me, during the checklist, you'll hear somebody say flaps, and the pilot flying will call back saying flaps 1 plus F. Now 1 plus F means we've got 1 notch of slat out and 1 notch of flap out. All right, so, and then once you accelerate the aircraft and you go above 210 knots, automatically the aircraft will retract the slat in, the flap, all right, which is at the back of the wing. Slats are in the front of the wing, flaps are in the back of the wing. It will retract the flap in and only keep the slats out. And then once you go flaps up, then it's going to retract all of them, all right, the slats and so on. Now if I was going to go to flaps 2, which I've just selected, as you can see, it's going to move the slats all the way out in the front, and that's going to give us 2 notches of slats and about 2 notches of flap as well, all right, and that's going to give you greater lift, but it's also going to create a lot of drag. Now coming back to noise abatement dictates when we can start accelerating the aircraft. Some procedures will have us climb very quickly to a high altitude before we're allowed to retract the flaps and slats and start accelerating the aircraft, because they want to avoid us accelerating the engines, or they want basically us to reduce the amount of power we're using on the engines to accelerate to higher speeds. And that procedure can sometimes be less efficient for the aircraft, all right? So, and then there are some noise abatement procedures that will have you basically reduce the power of the engines as quickly as possible, maintain a minimum speed around the area, and once you're away from that area, then you can start accelerating the aircraft, all right? So those would come in the form of speed constraints and altitude constraints to make sure you're high up above the built-up areas, and of course you are not using the engines to throttle and go faster, so you have a speed restriction. And once you get out of there, then you can start to clean up the flaps and then accelerate the aircraft. So I'm going to leave some links in the description box below for you guys to have a look at. Now because I want to show you all of this from an operational standpoint, and I'll let you guys do the whole reading stuff on your own time, okay? Now if I go for flaps 3, you can see that the slats stay where they are and the flaps move to the 3rd position. Going for flaps full, now the slats go all the way out and the flaps go all the way out as well, and that would be the full position of the that will be basically the slats and flaps extended to their maximum position. Now flaps and slats, they are super important to us as pilots, because what we need to do is, when we're taking off, we're starting from 0 and we're accelerating to a takeoff speed. Now that's pretty fast, but it's still not as fast as the aircraft would like to be flying. And so that's why we use the flaps and slats in an aeroplane. Any aeroplane, not just the A320, every aircraft from the tiniest Cessna and Piper all the way to the 747, Airbus A380, this aircraft, the Airbus A320, Boeing, you name it. Doesn't matter what aircraft it is, every single aircraft in the world will have a flap and slat system. Sometimes they don't have slats, they only have flaps. But generally speaking, all aircrafts will have lifting bodies built into the wing that you can extend to increase the amount of lift that the wing is generating. It helps you to fly at slower speeds. It helps you to keep the nose at a lower angle so that you can see while you're coming to land, and it's just a useful thing to have. So if something happens and they get jammed, and there have been situations where they did get jammed, then the pilot has a very specific procedure that he or she is going to have to do to operate the aircraft normally and safely. All right, so what I'm going to do is I'm going to be taking off from London Gatwick, putting myself on my way towards towards the Netherlands, towards Amsterdam. And then we're probably going to encounter a oh, that is such a tongue twister, I'm so sorry, the slats and flaps jam situation. And then I'm going to show you how we're going to deal with that and how we take care of it. Guys, if you're not subscribed, please consider subscribing. If you like our videos and you like what we do, please smash that thumbs up button. It works. I tested it just this morning. And yeah, let us know your comments in the comment section below. That's what it's there for. And if you've got any questions on anything you see in this video or any of our other videos, just let me know, guys. All right, without any further ado, let's go plan our flight to Amsterdam, and let's look at these noise abatement procedures as well. See you guys there. All right, here we are in SimBrief, and we've updated the ARAC as well. So we've got a fresh ARAC good for another 28 days. So we're current in our information. And I just went ahead and plugged in all the details, put our waypoints, aviation details, and we're taking off from London Gatwick, and we're going to Amsterdam. And as our alternate, I'm taking London Heathrow Airport as well today. All right, so as you can see, the flight plan basically takes us out of London Gatwick and all the way down there, and then we're going to make a little left-hand turn towards north, and then we're just going to be basically crossing the English Channel and then making our way into Amsterdam right over there. That is the flight plan. All right, and we'll be cruising at flight level 290 today, and yeah, we're taking 6 tons of fuel with us. We're going to be burning off 2 tons, but we'll keep 30 minutes as well, plus contingencies, all that kind of stuff. And today we're pretty light. We've got a takeoff weight of 65,160 tons and a estimated landing weight of 63 tons today. Now, looking over here, if I'm going to bring up the PDF of this flight plan, waiting for it to load. Alright, here we go. Here's our PDF. So as you can see, Echo Golf Kilo Kilo to Echo Hotel Alpha Mike, Gatwick to Schiphol. Alright, we got our standard cost index of 25. We're expecting to have a takeoff weight of that much and a landing weight of that much. And this is our fuel figures. We're going to be taking, so for the alternate, we've got, so the trip fuel is this much, contingencies is that much, and so on. And then of course our usual 30 minutes of whatever. We're not tankering any fuel with us today. All right, now coming down to the second page, you can see that we're going to be using the Frame 1 Zulu. We're going to use runway 08 right to the Frame 1 Zulu SID, which takes us out towards this waypoint called Frame, and then we're going to join the airways and on our way towards the towards Amsterdam. So now if I come up, so with all this in mind, if I come up to our Navigraph charts, what I want to do is I'll come to flights, I'm going to unload everything, and I'm just going to go import and import from SimBrief, and then right there, that's our flight. Going to click on that one. So as you can see, it's already got all our details in there. It's got the airport information, the 20-9 plate, and it's basically telling us what we you can see that's my aircraft right over there. We're going to be using runway 08 right, which is going to be this guy over here. Oh, actually 08 left, I believe. Stand by. 08 right it says, but I'm going to change that to 08 left. And we're taking the Fran 1 Zulu. All right, so given actually 08 right over there, I'm sorry, which is a longer runway, perfect for me. All right, now the main thing I'm looking at over here is if you look at the Fran 1 Zulu, so I'm referring to plate number 20-3 Hotel, effective the 13th of August. It's an RNAV SID for London, Gatwick to be more specific. Transition altitude is 6,000 feet. RNAV 1 and SIDs are available for, only for approved aircraft with GNSS, which is what we have. And so basically what we're looking at over here, this is going to take us from runway 08 right on an initial track of 077 degrees for about 4.9 miles. all right? And then we get to this waypoint over here, where we have a maximum speed of 250 knots, and we have a minimum altitude of 2,000 feet, a maximum altitude of 5,000 feet. Now coming over to the right, as we make a right-hand turn to 0901 degrees, we've got maximum speed again of 250 knots, and this time we're going to be going a little bit higher, and that's basically where we're going to be climbing. But I'm going to try and get to 5,000, since 5,000 is the threshold over here. And then as we go along, finally we get over here, where you can see we have to be at 5,000. No ifs and buts, not above, not beneath. We have to be at 5,000 feet by this waypoint over here. And then once we got the same restriction over here and the same restriction right over here, which is the Detling VOR. Now after Detling, we're going to be going on towards Fran, which is going to be the last waypoint that we have, and then we're on to the airways. So that's how we exit the SID and we get onto the airways. And as you can see, it's got a 250 knot speed limitation all the way. All right, you're not allowed to accelerate higher than that. Okay, and it says also, there's a warning, no turns below 710 feet. So when I take off, and I need to make sure that I do not make any turns until I'm above 710 feet. Given the performance of this aircraft, that's not even a factor. That's that's going to bother me today. All right, so I've got my VOR and everything that I've got to that I've got to follow. And another warning over here. Lots of warnings in the UK. All right. It's a stepped climb, all right? Due to interaction with other routes, pilots must must ensure strict compliance with the specified climb profile unless cleared otherwise by air traffic control. So unless they tell you to do something else, you got to follow this restriction over here. Now that is for the airport, okay? And as you can see, if I bring up the airport plates and bring up the airport briefing, which is right over here. Now in the airport briefing, this is where you're going to find your noise abatement procedures. All right, I'm referring to 20-1 Papa, and it says in section 1.2.1 under general, the following procedures may at any time be departed from to the extent necessary for avoiding immediate danger or for complying with air traffic control instructions. So they do have the procedure, but they're not super strict on it if safety is in consideration. All right, so so you can avoid these noise abatement procedures if air traffic control clears you to do so, or if there's a danger to the aircraft. All right, I have an engine failure or something and I can't climb quickly to get up and above all those houses, I'm gonna have to stay low and climb gradually without stalling the aircraft, that kind of stuff. All right, you also see that the every operator of aircraft using the airport shall ensure at all times that aircraft are operated in a manner calculated to cause least disturbance practicable in areas surrounding the airport. All right, and I'm going to show you what I'm going to do with this little thingy over here. All right, so avoidance of reverse thrusters. Okay, avoid use of reverse thrust after landing between 23:30 and 0600 local time, except for safety reasons. Now when it says avoid using reverse thrust, what they mean is full reverse. Like in the Airbus, I have idle reverse and then I have full reverse. All right, maximum reverse. So if I land, I'm going to be using idle reverse, which is going to be sending idle power about 20-something% out of the reverse thrusters, instead of giving maximum reverse, which is going to spool up the engines to 60-70%, and that will cause the noise from the engines to spread, the thrust and the noise from the engines to spread to the areas around the airport. So that's why they have that restriction over there. All right, now use of APU. All right, so fixed electrical ground power must be used whenever available and serviceable. Use of aircraft auxiliary power units and ground power units are strictly controlled to minimize environmental impact. By environmental, they're talking about, you know, the whole impact on the environment as well as noise, all right? Because, excuse me, when you start an APU, that's a jet engine. It's going to have a noise, so they don't want aircrafts using their APUs much in this airport. APUs must be shut down after arrival and only restarted before departure according to the time scales described in detail in published airport directives and notices. All right, now if you look over here, you can see now we are a narrow body aircraft where we fall under category Charlie, the Airbus A320. So the APU must be started before the scheduled block off time, the SOBT, not more than 15 minutes prior. Now generally we would start the APU, get the air conditioning going, all that kind of stuff, but because I'm not allowed to use the APU to start these engines until 15 minutes before my pushback, I have to keep the APU off. So right now I'm at the gate and I have the APU turned off. I'm using ground power, and I actually requested ground air as well, so that, you know, I've got air conditioning coming in from the aircraft from the ground units. And after I arrive, I can use the APU on the stand for not more than 10 minutes. So I'll land, I'll start the APU, I'll taxi in, and as soon as I taxi into the gate, I have to have the APU shut down after a maximum of 10 minutes. All right, so you gotta work quick with the ground crew. All right, and of course the exceptions and restrictions are all over there. You guys can read that for yourself. All right, and so that's pretty much how we're going to be looking at those noise abatement procedures. And then if I come to the reference section over here, the noise abatement diagram for the RNAV SID. Now my SID for today is the Frame 1 Zulu. So if I look over here, plate number 20-4, effective the 25th of February, noise. All right, so you can see that when you're taking off in that direction over there, which is the runway 08 left and 08 right direction, the Frame 1 Zulu does fall under these noise abatement procedures. All right, so given that they've got these monitoring stations all over the place, they've got a monitoring station right over here, you got another monitoring station over here, so you know all these places are just meant to ensure that you do not break those noise limitations. Okay, so you can see over this side we've got all of these SIDs that fall under noise abatement procedures. Now for me it's the Frame 1 Zulu. All right, so you can see all of those things that are related to it. And then on the other side you've got these SIDs that fall under noise abatement as well. So you can look at this plate and you can study it and you can see what happens. Now as I was saying, when I look at the Frame 1 Zulu, you can see it's going to have me at a minimum altitude of 2,000 and a maximum altitude of 5,000. All right, and accelerating to 250 knots. So what I'm going to do is I'm going to try and program my thrust reduction acceleration altitude to reduce the power, to basically bring the power back quickly, and then do a nice gentle climb up to 5,000 maximum. All right, so I'm going to program that into the box, and we'll see how that goes. All right, in terms of our airport diagram, we've got 10,883 feet of runway, plenty of runway if I need to abort, and the taxi looks like it's going to take me, if I go over here and I zoom in on my airport right over there, looks like I'm going to be pushing back from the gate where I am, which is gate 567, onto Quebec Alpha. I'll take Quebec Alpha all the way down to Lima, make a right on Lima, and potentially I can even take I'll probably go straight down Lima, make a left onto Sierra, come down to Juliet, and then all the way down on Juliet, over to this section over here where I can cross runway 08 left and line up at runway 08 right. Okay, so that's my taxi out procedure, and I'll program in my V speeds as well shortly after this. So guys, that's pretty much how I'm going to be looking at all this noise abatement stuff, and yeah, all we got to do now is just head over back into the cockpit and program all this in and just get ready to go. So I'll see you guys back in the cockpit very shortly. Alright guys, back in the cockpit. I've programmed my entire flight plan in. As you can see, I've got all those constraints in place over there. So if I come over to the flight plan page, you can see that as soon as I take off in about 5 miles, I have to be at 250 knots, 2,000 feet or higher, and so on, climbing up as we go along. And then once we get to Frayne and we pass Frayne, whatever, then we can go on to higher altitudes. All right, so that's our noise abatement procedure right over there. So my idea is, now generally when you program the MCDU, over here you see thrust reduction and acceleration altitude. Okay, so this is the altitude. Thrust reduction, acceleration altitude is the point when the aircraft starts to nose down from your initial climb angle to start accelerating and basically, so the thrust reduction is because when I take off, today I'm doing a flex takeoff, right? So I'm gonna have the engines over here in flex takeoff mode, which is right over there, flex. All right, so the engines are going to be here in flex, also known as maximum continuous thrust. Now, thrust reduction altitude is the altitude at which I will get lever climb flashing over here, and that's when I need to bring the thrust levers back to climb. All right, and then it's going to reduce the amount of thrust, thus reducing the amount of noise the engines are making. The acceleration altitude is where basically the nose is going to dip down and it's going to start wanting us to clean up the aircraft. Now this is going to happen pretty quick because we need to get to 250 knots. We need to get to, actually the maximum speed is 250 knots. All right, so it's not going to let us climb. So we need to basically not fly faster than 250 knots as we go around, as we get to those waypoints there. Okay, so very strict noise abatement procedures in place over here. Well, not so strict, but strict enough. All right, so what I want to do is to keep things nice and quiet, I'm going to keep the thrust reduction altitude. So London Gatwick is about 203 feet above sea level. All right, so what I'm going to do is I'm going to set the thrust reduction altitude to let me see, I'm going to set it to about 1,000 feet above the ground. All right, so that's 1203. Okay, that's going to be the thrust reduction acceleration altitude, and I'm gonna set the acceleration altitude to 5,000. All right, so I'm going to reduce my thrust at 12,203, and I'm going to drop the acceleration to 5,000. By that time, I would have reduced the thrust in the engines, and then at this altitude, I would have started accelerating the aircraft, spooling up the engines and everything to accelerate and clean up the flaps, and that would help me out to keep things nice and quiet for all those lovely people who live around the airport. Okay, so that's done. Now, given with the noise abatement procedures, I've got my APU turned off. As you can see, the APU is off. If you don't believe me, I'm going to show you right there. You see, no APU. I've got ground power and I've got ground air. All right, the ground air unit is also connected to the aircraft, giving me the air conditioning I need right over there. You can see it goes into pack 1. I can always open up the cross bleeds, and then it can go into pack 2 as well. And we could literally use the ground. We could usually use the ground air to start the engines as well. But I'm going to be using the APU. All right. So what's going to happen now is I'm going to basically start the APU, request the pushback. All right. And as soon as I'm ready for pushback, I'll start the engines and get going. In fact, I'll probably start engine number 2 first, and I'll do a single engine taxi all the way down to the runway, and then as I'm holding short of the runway, I'm going to start engine number 1, and that's also going to help me to reduce the amount of noise I'm making around this airport. All right, so yeah, that's the plan. APU, start engine number 2, and then once I've got the once I've got engine number 2 running, I'm going to switch off the APU, and then I'll do an engine cross bleed to start engine number 1. All right, and that's going to help us keep the noise down in this airport and get going. All right, so guys, let's go ahead and do this procedure. And again, if you got any questions, feel free to ask me in the comments below. All right, so let's go ahead and start the APU first. So I'm going to do an APU fire test. Let me get my nav thingy going there. APU fire test. All right. Okay, APU fire test is complete. Gonna hit the master button there. That'll bring up the APU page at the bottom. And gonna hit the start button right there. And that is gonna start the APU. Once the APU is available, I'm gonna have them, I'm gonna request for push and start, basically. So yeah, waiting for the APU now to start up. And while I'm doing that, I can tell the ground crew to, you know, take the bridge away. And also I'm gonna tell them to prepare for our departure. So here we go, they're removing the bridge. The jetway is going away from the aircraft, and very soon the ground person's gonna come and help me push this aircraft back and start my engines. All right, so APU is still starting, and I'll get back to you guys in just a second once we're about to start. All right, they want me to release the parking brakes. Gonna come over here, release, and we're off blocks 0701. All right, so she's cleared me to start the engine, so I'm gonna go ahead, start engine number 2. Go to ignition start, brings up the engine page over there, and up and forward, and restart the timer. There we go. Pushing us back, we're starting engine number 2. So we've got the APU running, and we're starting engine number 2. Hello, Gatwick. And it is a beautiful day for flying today. Visibility is good, cab okay conditions, QNH is 1016. Initial climb we got 6,000, but we'll be following our constraints, so we'll be doing a managed climb all the way out. Here's a TUI 787. Nice. Alright, question for you guys. Are you a Boeing fan or an Airbus fan? Well, you must be an Airbus fan, that's why you're on my channel. But I like them both. I like them both, so yeah. Let's see. Alright, got a British Airways 320 over there, and you got a EasyJet over there in the distance as well. Alright, so now we've got the engine number 2 started. I'm gonna go ahead, put this back to normal. I'm not gonna start engine number 1, and immediately I'm gonna go ahead and turn off the APU bleed and turn off the APU master. Alright, and that's gonna help me to basically set things up as well for my single engine taxi over to the runway. Alright, so what's gonna happen now is she's going to disconnect, and I'm gonna do a single engine taxi over, and then I'm gonna bring up the procedure for the single engine taxi. Yes, ma'am. Parking brakes are set.
Waiting for confirmation for a good engine start.
Alright, confirmation for good engine start. Let me do that.
Update to ground. We have a good engine start. You can disconnect.
That's my other voice. Alright, so now she's going to excuse me, guys. Something is in my throat this morning. I'm so sorry. Alright, so she's disconnecting now, and we're basically going to be doing a single engine taxi down to runway 08 left. We'll hold short over there, and then we're going to start engine number 1. Alright, so I'll get back to you guys when I'm doing that procedure. See you then. Alright guys, we're here holding short of the runway, but there was a slight change in plans. Due to the winds being variable today, we're not going to be using a runway 08 left, but rather all traffic has been moved to runway 26 right, which required me to make a quick change of plans. So essentially speaking, It's I'm gonna have the chart on the screen for you as well. We're using now the Frame 1 Victor departure, and so basically what we're going to do is we're going to be taking off on runway 26 right, 257, maximum speed of 220 knots, and we have to be at a minimum of 1500, maximum 4000, make a pretty much a U-turn, and then we're going to be climbing to a minimum altitude of 3200 and 4000, followed by that one over there, and then onwards over there. All right, so that's basically the procedure we've got for us going today, the Fran 1 Victor, and I need to change that. So I'm going to come over here, I'm going to go to departures, I'm going to choose runway 26 right, and we're doing the Fran 1 Victor. All right, and I'm going to insert that in there. Okay, now the next thing I want to do is basically I'm just going to come into plan very quickly. Oh, we got an EasyJet taking off on runway 26 right. Sweet. All right, I've got all the constraints in there as well, so that's looking good. And just want to make sure there are no discontinuities. And yep, there is one. I'm going to clear that discontinuity from there, insert it, and everything's looking good as of right now for the takeoff. And it's going to be a flex takeoff of 66 today. And our speeds are going to be 140, 144, and 149 for the takeoff. All right, thrust reduction acceleration, I'm going to leave it at that. All right, and yeah, actually, in fact, I'm going to change this up to 1500. All right, so there we go. And once I get to 5000, I'm going to start accelerating the aircraft. All right, so that's pretty much done for that. Now it's time to do a cross bleed start. So the first thing I'm going to do, because I've got engine number 1 shut down still for noise abatement obviously, so I'm going to open the cross bleeds in the in the air conditioning panel, and that should eliminate the pack 1 fault. There we go. All right, come over to the bleed page. As you can see, we're bleeding air from engine number 2 to engine number 1. And now I'm going to go ahead and start engine number 1 using cross bleeds, using the bleed air from engine number 2. So first things first, go to ignition start, and I'm going to switch on number 1. There we go, engine is spooling up. To help it out, I'm just going to give a little bit of thrust. I'm going to give about 25 to 30% of thrust on engine number 2. It's going to help to spool up that engine, get some good bleed air pressure. I have no idea why it's saying that. Engine 1 start fault, low start air pressure. Oh, okay, which means it wants more air pressure. There we go, gave it a little bit more thrust, and that took care of that problem. The engine has spooled up. N2 is climbing, N1 is climbing, fuel flow is in, looking good. So whenever you do a cross bleed start, you do have to give a little bit more extra power on that engine. So about 35% was what we needed today. All right, excellent. That engine is spooling up very nicely. Very soon we're going to have a nicely started engine. There we go, engine number 1 has started. So now it's time to bring engine number 2 back to idle. All right, engine 1 is available, so we're going to go ahead, cross bleeds back to auto, and I'm going to go ahead and complete our takeoff memo. That should complete the takeoff thrust. TARA on the TCAS, auto on number 1, weather radar is on. Everything's looking really good right now. Alright, so it's time for us to do the takeoff, guys. Get back to you very, very shortly. We're just about to do the takeoff. I'm just gonna do some stuff, wait for this guy to take off, and then we're off. Alright guys, time to go. We got another aircraft land on runway 26 left. Alright, let's go. Lights coming on. And let's get the parking brake off, and let's taxi on down to our runway. I hope the AI traffic doesn't send somebody into me. Oh look, we got AI all over the place. I'm just waiting to get my ATC add-on done, and then that should help with that. Alrighty, is he gonna hold short or is he gonna move? You know what? Let's just go. Alright, I think they're gonna wait for me. I think he's also gonna wait for me. That's alright. We'll see what happens. Alright, 50% on the engine power. And let's go with takeoff thrust. Okay, Manflex 66 SRS runway auto thrust blue. Airspeed's alive. Here we go. Oh, he is waiting for me. So kind. There's 100 knots. V1 and rotate right at the end of the runway. Okay, climbing up, getting it on the flight director's positive rate, landing gear up. Autopilot comes on immediately to help me out with my workload. And you can see I'm going to reduce my thrust acceleration, my thrust reduction at 1500 feet. So let's see. So as soon as we reach 1,500 feet, I'm going to get lever climb. Alright, there's lever climb at 1,500. So now I'm going to bring this back, one click. And we got thrust climb, auto thrust wide. And we're pretty much going to maintain 160 knots. Climbing to 6,000, manage. So we've got 4,000 in magenta over there to show our constraint. And that's basically it, guys. So now I'm not going to accelerate. We're going to stay here until 5,000 with the flaps out until it's time for us to go ahead and clean up and accelerate the aircraft. All right. So that's pretty much what's happening right now. All right, guys. Get back to you in just a second when I'm about to do my cleanup. Alright, so we're flying along and we're basically just getting close to our altitude. And once we get past our restriction of about 4,000 feet here, we can then climb. And we're going to maintain about 4,000 over here just to make sure that we don't bust the altitude constraint. And yeah, everything's looking good in terms of the noise abatement procedure. And as we move along, things are looking good. So we performed the takeoff, we got high enough, and we're accelerating. And good lord, what do we have now? Okay, so master caution, flaps slats locked, wingtip breaker on, maximum speed 215. So we're going to quickly pull this, make it 215 for the maximum speed. In fact, I'm just going to lower it down to 210. All right, and continue with this. Max speed 215 knots, fuel consumption is increased, and the FMS prediction is unreliable as of this point. I'm going to clear that, and then the flaps are locked as well. Wingtip breakers on, maximum speed 215 knots, fuel consumption increased as well. FMS prediction is unreliable. So essentially speaking, what has happened is the flaps and slats have jammed. All right, and the wingtip breaker for some reason has chosen to lock them. Now with the wingtip breaker on and the slats and flaps pretty much jammed in that position, if I try to move them to flaps up, you can see they're locked in that position. They're not going to do anything. All right, if I try to go flaps 1, or still the same problem, then I'm going to see flaps 2, they're not moving. The flaps and slats are jammed. All right, so there's nothing I can do. So I'm going to keep the flaps at 0, and I'm going to maintain a clean speed. So today our clean speed It's just under 215 knots. So what I'm going to do is I'm going to keep it at 210 for now, and I'm going to basically climb up to 5,000 feet so I stay within the MSA of this area, and I'm going to request a hold at Acorn so that I can kind of you know, so that I could kind of see if I can fix this problem and see what happens. So we're going to go an inbound of 075, and it's going to be a right hand turn, and I'm going to insert that, and there we go. There's our hold at Acorn, and we're just going to be in the hold until we can get this problem resolved. So right now on the status page it says the fuel consumption has increased. The fuel procedure, the approach procedure for this situation is to use a flaps 3 landing. Center tanks must be off, and the GPWS should be flaps 3. All right, and the approach speed is VREF plus 15, and a landing distance procedures apply. Now, given that this situation is going to keep us with flaps and slats out, all right, and we cannot slow the aircraft down anymore, because what's going to happen because we risk stalling the aircraft. All right, so what we want to do now is we basically need to look at some parameters over here. Like for example, if I was to bring up the airport information at Gatwick, all right, let me try to bring that up here. So the airport information, so Gatwick will probably be using runway 26 left for the approach, which is a 10,800 foot runway. That's really good. All right, and that's probably going to be enough for us. Now looking at our landing weight, our maximum landing weight is 66 tons. We're at 65,100 tons, so we can go ahead and do this landing. Now also we would need to jump into the QRH of the Airbus A320, and we're gonna have to go into the abnormal procedures, and we go over to flight controls, and we go to landing with slats O flaps jammed. All right, so as it says, repeat the following procedure: VFE plus next minus 5, and I need to calculate my distance for the landing. All right, if it's a slats fault, maximum speed is -10, diversion flaps fault -10. All right, and then the green or yellow system should maintain close speed to the VAPP. If flaps are jammed at 0, select the clean configuration. If the flaps and slats are jammed at greater than 0, which they are, they're in the 1 position. Recommended speed for diversion is maximum speed -10. All right, so that's pretty much what we got to do now. So we're gonna have to bring this aircraft in and do a high speed landing. All right, so when landing configuration on final approach, flaps 0 will be 230 knots, but we've got a maximum speed of that. And then we've got, all right, 215. Okay, it's this one here, 1 plus F, that's where they're stuck. So the speed is going to be 200 knots that we want to maintain at all times. And yeah, that's pretty much the limitation I have right now. So the situation now is for me to bring the aircraft in and land it in a very high speed. This is going to be a high speed landing for sure. Okay, so what I'm going to do, declare my mayday, blah blah blah, all that kind of stuff, and I'm going to go ahead and I'm going to go to secondary flight plan, copy active. I'm going to change this to Echo Golf Kilo Kilo. Actually, no, I'm not going to do that. I'm actually going to go here, and I'm going to take a waypoint after this, and I'm going to go new destination Echo Golf Kilo Kilo, put it over there, insert. Now at Echo Golf Kilo Kilo, I'm going to go ahead and go for the arrival. We're going to do an ILS into runway 26 left, no stars, insert. All right, we're going to be vectoring our way back in there. Now after that, what I want to do is I'm going to do the RNAV page. We're going to be let me bring up the chart here for runway 26 left, which is that one right over there. So the approach for runway 26 left, frequency is 110.9 with a final course of 257 degrees. And for the final approach segment of this, the minimums are at 396. All right. So, and there is a VOR, which is the Mayfield VOR. So on the RNAV page, I'm gonna put May in there and put May on the top as well. Frequencies are correct. Progress is going to be Echo Golf Kilo Kilo 26 left over there. And I'm going to come over to the performance page and I'm going to go to the QNH. Let me get the updated information for London. I hope you guys can see my screen. Alright, the updated information is variable at 1 knot, cab OK 20. Alright, looking at the ATIS information, Gatwick Information Airport. And QNH is 1016, it's information Bravo. And runway in use is 08 right now with an ILS approach to be expected. Ah, interesting. Okay, so it's 08 right. Fair enough. Okay, so let's go back over here and let's pick, yep, ILS 08 right, insert. Okay. So we've got the runway in there, we've got the RNAV in there as well, we've got progress, performance now with for runway 08 right, which is now the runway I need to look at. Alright, ILS for runway 08 right. Frequencies are checked, all good. And yeah, the minimums here are 396. Alright, so the QNH is 1016. Let me just double check that. Yep, the QNH is 1016, and I'm gonna put that in there. The temperature at the airport right now is 20 degrees. The winds are variable at 1, so good conditions. And our minimums today are 396. All right, gonna go there, 396. So that's the situation I'm having. And what I need to do now in operating systems are the flaps and slats. Fortunately, they're a little bit out, which kind of helps me out. But yeah, now it's time to basically go ahead and vector ourselves back towards that runway. All right, so we're gonna come out of our hold, and we're basically gonna go on a right-hand downwind for that runway. So I'm initially gonna go to a heading of 240. The approach starts at 3,000 feet, so going to descend down to 3,000, and we're keeping 200 knots. And yeah, and what I'm going to do is I was going to tell the aircraft we're going to do a flap 3, config 3 landing as the QRH says to do so, and I'm come up here and select config 3 as well on that. Now the good thing, this is an ILS, so that's going to help me out in terms of getting the aircraft down. Now I'm going to also go with medium auto brakes on this because I'm going to need as much stopping power as I could possibly get. So medium auto brakes, I'm going to clear this. We've done our landing distance, we've got what we need in terms of our calculations, and the aircraft now is essentially trying to slow itself down. Now if you look over here, there's my minimum speeds right over there. All right, now what I'm gonna do now is I am going to start configuring as quickly as I can. All right, so I'm gonna go ahead and give the aircraft flaps 1. Now as you can see, the bobber pole comes down and the speed limitation is there. So we've got flaps 1. It says to use flaps 3. So I'm going to go ahead and I'm going to select flaps 3. All right. Now I selected flaps 3, but the flaps and slats are not going to move. All right. I'm just keeping it in that position for the landing. All right. And we've got config 3 selected there as well, and config 3 selected there. So that's pretty much it that I can do for now. And I'm gonna now reduce my speed so that the aircraft is flying in a safe manner. All right, I'm gonna bring it back down to about 160 knots. I'm gonna dial in 160, and that's gonna help the aircraft to stay below the maximum speed and definitely above the minimum speed. So we're still okay. Gonna clear this message over here, and the only thing left to do after this would be to get the landing gear down and then make the turn for final. All right, so guys, I'm going to be flying out, so I just want to The final approach fix happens at India Golf Golf, which is Foxtrot. So I'm going to now sequence my flight plan, which is Foxtrot 08 right, and it's going to be a radial in of 257, and I'm going to pull that heading. So now I have basically sequenced my flight plan, and I've got 30 track miles to go. There's the airport right over there. Going to make my way around, join the ILS, and bring the aircraft in for a landing. So yeah, so now looking at this, flaps 3, my lowest speed will be 140. I cannot land any slower than that. All right, so this is pretty much not too bad. All right, the situation's not so bad, but again, you know, if the flaps and slats were jammed at 0, then this would probably be a higher speed. So keep that in mind. All right, so it all depends on where the things get jammed, where they get locked. Fortunately for us, we're at one notch of slats and 1 notch of flaps, so we're going to be coming in a little bit more faster than usual, but it's still at least not so bad that we're going to go a flap 0 landing, and that's going to be very, very fast. And then definitely runway distances are going to be crazy for us. And I'm going to let the ILS do a full auto land for me so that I can focus on retarding the engines and whatever. So yeah, get back to you guys when I'm just about to join the ILS and perform the final approach. See you guys there. Alright guys, here we are. We're about to capture the localizer and the glide slope for runway 208 right. There we go, lock star, glide slope star, and the aircraft is starting its descent right onto the glide slope to capture it. And the go around altitude in for runway 08 right is 3,000. So we're going to keep 3,000 up there. Now, as you can see, the aircraft is descending, but it's not accelerating. It's not slowing itself down. So I'm going to try and use some speed brake to help me alleviate that speed increase. And I'm gonna lower the speed down to about 150 because I think 150 is a safe place to be. And now we're gonna get the landing gear down as well. That's gonna help with our speed as well. Alright, gear down. Alright, gear down, 3 green. I can arm the spoilers now. So now our speeds are going to be kept at 150. So 150 is just above the minimum speed and definitely not busting through the maximum speed. All right, so we're at a safe place here. We're probably going to have a higher angle of attack than usual, but it's okay. We're fine. Landing checklist is completed. We got landing no blue, and as you can see, I've selected flaps 3, but they're stuck in the 1 position. There's nothing I can do about that right now. Alright, there's our runway coming into view. We've crossed 1,000. All systems are checked, and we're proceeding for the landing. Okay. Not how I wanted to start my morning, but yeah, that's fine. These things do happen. And I've decided that the runway is actually long enough. I'm gonna stick to auto brakes low for this one, because my airspeed's not too high, so we're still okay. If I was going to be landing at a much faster speed, I would go with medium auto brakes, because that will really slow us down. But yeah, using the Airbus computers to its maximum, I'm just basically going to be allowing the autopilot to do this landing. And when it says retard, I'm going to bring the thrust levers to idle, engage reversers, and hopefully we stop before the end of the runway. Okay, we've got land, and we are now committed to our landing. 150, just right on that F speed as well, so our parameters are good. 300 feet. Here comes the runway. 100 above.
200. Minimum.
All right, continue.
100.
Aircraft is now going to go into the flare.
50. 40.
There we go.
30,
it's flaring.
10. Retard.
Retard. Okay, engines are retarded. Rollout's happening. Auto brakes are working. Quickly pull the reversers. Spoilers, reversers green. And we have decel. Autopilot is keeping us nice in the center, and the aircraft is decelerating. Alright, very good. Here comes the end of the runway. There's 70 knots. Back to idle reverse and full idle. And we'll bring the aircraft to a stop at the end of the runway. Alright, going to turn off the autopilot now. And I'm just gonna stop the aircraft on the runway. We've got the fire team coming as well. Alright, cool. Set the parking brakes. Alright guys, so let's do a little recap here on what we learned today. So we took off, and unfortunately slats and flaps were locked in the number 1 position, and from that point on we couldn't move them. Alright, so they were jammed. So we did our quick calculations, and we were able to determine that we can come in for a landing with this runway 208 right, because it was long enough and gave us plenty of distance to stop the aircraft. We use auto brake low and maximum reverses. Now in the NOTAMs, or rather in the instructions we read earlier for the noise abatement procedure, it said to not use reverse thrusters unless in an emergency situation. All right, so this definitely qualified as an emergency situation, which is why as soon as I landed I went maximum reverse, and as soon as I hit 70 knots I went to idle reverse and then full idle. And I can actually now shut down engine number 1 and just keep engine number 2 running, and that should help us out as well with the noise abatement stuff. And now when I taxi over to the gate, as soon as I taxi to the gate, I'm going to start the APU now as well. And then as soon as I get to the gate, I'll shut down the engines, get the electrical power going, and then I'll shut down the APU as well, guys. So guys, that is how we deal with the flaps and slats situation. The good thing about the Airbus is you still have the autopilot, you still have the auto land feature, you still got everything helping you out. So use those tools to your advantage to bring you back down safely. All right, and yeah guys, if you got any questions, feel free to let me know in the comments below, and I'll be happy to answer you. And yeah, thank you so much for watching. If you're not subscribed, please consider subscribing, and if you like the video, hit that thumbs up button. And yeah, thank you guys so much. Wishing you all the very best for the rest of your day. God bless you, and I'll see you in the next one. Bye bye.
Hi, do you live in Dubai, or are you in the United Arab Emirates? Are you an aviation enthusiast? Do you play flight simulator on your computer at home? Would you like to have the ultimate experience of flying an Airbus A320 in a real cockpit environment? Or are you a real-world pilot and you're looking to practice for an upcoming airline assessment? Or do you just want to master the Airbus aircraft? Are you a pilot looking to level up your knowledge and experience in instruments and navigation? Or maybe you're thinking of becoming a pilot in the future, but you're not yet sure if this is the path for you. Well, whatever your requirements may be, we're here for you. Book a session in our Airbus A320 flight simulator and come experience flying with a real-world pilot by your side as your instructor, guiding you along every step of the way. All ages are invited. Just scan the QR code or contact us via the details below for more information. See you guys in the cockpit soon.